Welcome back to CP0. So in this video, I want to give pointers to some resources and also suggestions on how to solve the problem, sort of a meta level suggestion, how to debug, and we'll see more concrete usage of those advices in the actual course. So first, there is a course homepage which contains information about this course. So here is the page. So other than the generic information, links to the problem sets, slides, and the videos are provided here. So resources for the first three topics will be publicly available, and later topics, those resources will be available in Bright Space. So these are for students who are taking the course. So if you take the CP0 course, then you will have access to the Bright Space, and then you'll be able to see those resources. So the problem sets are all on HackerRank, the website HackerRank. So you can take the course without installing any new software on your system. So if you, in addition to solving the problems from the course, you also want to try some C++ code and see what they do, you can use an online IDE. So here I provide the link to two of them. And there are other C++ IDEs, and some of them have GDB integration, so that's debugging tools. But I think they're using GDB is unnecessary for CP0. We can use, I would actually recommend using simply printing to debug your code, because I think doing that, it requires more logical thinking. GDB sometimes it's sort of more, you can do debug a little bit using less thinking and more mechanically, just going through your code's execution and see what things are wrong. If you do want to install a C++ environment, then what you need to do will depend on the computer, the operating system your computer uses. If you are using Linux, then I assume you already know what to do. So in general, C++ is already installed on a lot of Linux distribution. If it's not, you need to install the C++ development environment, the development packages on your system. If you're using Linux, I kind of assume you should be able to figure that out. If you are using Windows, I recommend installing Cygwin 64-bit on your Windows system, and then you have then you need to install the C++ development package, and then you can use any editor to edit your code. I use Notepad++, and use the Cygwin to compile and run the code. So within the context of the course, we'll provide more help on how to install this on your system. But at least for the beginning, several topics you can do a lot without actually need to install the C++ environment. You can certainly solve all the, you can go through the course without having to install C++ environment. I don't use Mac, so if you use Mac, you can find the information. Again, if you are taking the course, we will provide help through the content of the course. So there are also online tutorials. There are many online tutorials on C++. So giving more detailed description of the language. So these you can use for reference. So if there are things that particular topic you want to learn a little bit more, you can go through the corresponding portions in the tutorials. There are also some practice websites. So if you want to get a little bit more practice on C++, then solving the problem for this course. So these are two sites that I recommend for this audience. So sort of not for people who are started learning to program. So Code Wars, there are many sort of entry-level programming assignment that you can log in and you can do, and you can look at other people's solution code as well. And also on HackerRank, they have this context for Project Euler. So Project Euler is a very interesting source of kind of mathematical problems that many of which can be solved using writing a program. Some people converted the Project Euler challenges into HackerRank to make them even more sort of programming oriented. So instead of just solving for one parameter in the original Project Euler challenge, now here you actually sort of really write a program and solve the problem in general. They're very interesting problem, and the harder ones are very challenging mathematically. So for those of you who are interested in math, I really recommend you to take a look at either the original Project Euler or this particular context within HackerRank. So don't start from the top, because the problem are listed in the let's actually take a look. The challenges are listed in reverse chronological order, and the later ones tend to be fairly challenging. So this is HackerRank Project Euler Plus. So you need to scroll down, keep scrolling down all the way. I suggest you start from the very beginning. So and look at the easy ones first, and while your programming skill improve, you can move on to the harder ones. So even some of the easier ones may not be straightforward when you just started learning programming, but some of them are definitely sort of suitable for beginners. So yeah. I think the first few, let's see, we're almost there. Yeah. So lots of interesting math problem here. Yeah, these are definitely easy. So even these, even this, I'm not. It may not be immediately easy for when you just start learning programming. Could be a little bit challenging. Okay. So debugging is an integral part of programming. So it's rare for non-trivial program, if you write the code and it works the first time you try. So after generally the first phase is you write the code, there may be syntactic errors. So then the compiler caught that, they will give you error messages, and in which case you should read the error message, especially look at the line number and the position number, and look at that position, look at the code, especially before the specified position, and see whether there are syntactic errors. But after passing the syntactic checking part, if you run your code and you get a different answer on a test case, then you need to debug. So basically when you debug, the first thing you do is you mentally execute your code on the failing test case and see what you think should be the output from your code. Now, if when you execute your code, the output from your mental execution, the output already differs from the expected output, the expected sample output, then you know your code is wrong. So you need to figure out how to change your code so that you will get the expected output. The harder situation is when you execute your code mentally, you think you get the same as the expected output, but actually your code doesn't. So in that case, you need to figure out where the execution of your code start to diverge from what you think it should do. So in order to do that, you essentially use a lot of printing statement. So by printing, I mean this output. So you can output to C out, but just as a good habit, output to CERR. So that's for printing error messages. In most execution environment, C out and CERR actually output to the same place, but just as a good habit, output use CERR for printing debug information. So you print the value of the important variables at different execution place, and you make it sure that when you print, it's clear which statement printed and what variable you printed. So you try to make the printing information a little bit self-evident so that when you look at it, it's clear. You don't need to spend additional brain power to figure out what your printed state information mean. So essentially, from the printed information, you can verify how the program execute, and at a different execution point, what are the value of the different variable, and see whether that matches what you think, and that what matches what eventually will be the expected output. So I used to joke that when I start debugging, either in a class or in a setting, I used to joke that now I will be starting using the state-of-art debugging technique of printf. Printf refers to the printing statement in C. But actually, more recently, I sort of attended some faculty candidate talk where the research topic is on debugging in distributed system. Well, in a sense, printf is the state of art. So when you try to find a complicated problem, a lot of time debugger does is to add additional printing statement into the production system, and then they see the output, and then they figure out what is what is the error and why it occurs. So also suggestion on how to handle harder problem in CP0. So for example, in topic 1, the Professor Goldluck problems are harder than the other assignment problem. So in general, when I include a hard problem, I will have a similar problem as an example problem, for which we will go through in the video lecture, and also there will be source code, there will be solution code available. So what I suggest is you first make sure you really know how to solve the example problem. So seeing the solution code and feel that you have understood it doesn't really mean you can solve that problem. So what I recommend is, after you watch the video, after maybe you read through the source code and think you understood it, then you solve the problem independently. So you write the code, and then you may run into errors, and then you try to debug it. But when you are stuck, when you cannot eliminate the bug, then you compare your code with the sample solution and see where they differ. So some differences may not matter that much, but there are maybe design differences that you can see, even though they don't matter in terms of correctness. Maybe one way of doing it will make it easier to understand the code and reading about the code. And sometimes there will be logical differences, and the logical difference will be probably sort of underlying reason for the bug if your code has bug. So make sure you really understand how to solve the related example problem, and then you can analyze the difference between that problem and the homework assignment problem, and then see in the logic where do you need to change in order to solve the homework problem. And another advice, this is really I think widely applicable for both programming and other problem solving, is when you have trouble solving the problem, or when you solve a problem and run into a problem, or in fact, even before you start solving the problem, make sure you actually understood the problem correctly. So read the problem statement multiple times and read it carefully. So I guess ideally maybe even read it out aloud, just to make sure you're really catching every word. And go through the samples. Make sure you understand how the samples work. So for those kind of tricky problems, really you need to make sure how you understand the sample works, because maybe your logic in your mind of how to solve the problem missed some situation. But if you look at the test sample, then probably you realize your logic have a mistake, and then you need to adjust your logic and your code to do that. It's much easier to make the adjustment before you start writing the code. So make sure you understand the test samples. I assure you, for hard problems, this will save you time. So in addition, some other suggestions: when writing complicated code, start by writing high-level description of what you want to do on paper first. So it doesn't have to be precise. It's for yourself to understand. But having the logic steps in the paper written down first before your code. And also add comment in your code. So while you write your code, explain to yourself what the code does. Because when you're writing later part, your eye can easily see your comment. And seeing is sort of a very fast way of putting things into your mind. So then you can put different pieces of information together and make sure your code is correct. And also name your variable with something meaningful. And also sometimes it's helpful to use state variables to encode information, and also use functions to make your code easier to read and write. So read and understand. So this we will illustrate using examples of how to use state variable and functions. And another meta advice is do not be afraid to start from scratch. So if you write a version of a code, and while you try to change it to adjust to the sample code, it gets more and more complicated. It's sort of still failing. I suggest you maybe take a break and then come back and then rewrite from scratch. A lot of time that's actually faster to get the working code than the original. And in fact, sometimes even after you solve a problem, you pass all the test cases, but your code is really complicated. I suggest you wait a day or two and then go back and rewrite it. So at least my personal experience, sometime working on a complicated sort of project assignment, I may get code to work, but this felt very tortured and complicated, the code that get it work. But the next day I rewrite it, and then it will be the process becomes much more fluent, because you already encountered the difficulty. Your mind know what are the pitfalls to avoid. So it will be much more pleasant the second time writing it. And also I believe this process you really learn a lot, because you want to write good code, and just writing code to work, that's one thing, but you really want to write high quality code that are easy to write and easy to debug. And rewriting is help in developing the ability to write better code.